Hello students, let me introduce myself. I am Puneet Thukral, working as Senior Lecturer in Physics. The topic which I have chose today for your home study is the second chapter from your 12th class curriculum, Current Electricity. After studying this chapter, you would be able to explain certain things, or you will be able to understand certain things. Electric current, charge carriers, conventional current, drift velocity, resistance, resistivity, conductance and conductivity, temperature dependence of resistance, and color coding of carbon resistance. Now, let me start. What do you understand by electric current? Now, all of must have understood it, or all of must have read it earlier, that electric current is nothing but the flow of charges. But to very precise, if I have to say that electric current is defined as the charge flowing through any section of conductor in 1 second. And if I have to write it in a mathematical form with the usual symbols, I is equal to Q by T, where the flow of charge is steady. Now, here I represents the current, Q represents the charge, and T is the time for which the charge is flowing through it. Now, we can write it in another form. All of you must have read about your first chapter, and if not, I have used one relationship, the quantization of charge. The quantization of charge represents that the total charge is equal to the integral multiple of the charge on electron, which I have written as Q is equal to NE, where N is the number of electrons and E is the charge on electron. So, the above relationship can be changed into I is equal to NE upon T. Similarly, if I have to say that the flow of charge varies with time or changes with time, we can say it that the current flowing through it is equal to dq by dt, however small the time is for which the charge is flowing through it. Similarly, if I say that what is current electricity or electric current, it is the flow of charge flowing through any section of conductor in 1 second. Now, the next one is the types of current. Before going to it, we must know that the unit of current is ampere. Now, I have represented different types of currents over here with the different type of colors. If you look at over here, I have represented a steady current which does not vary with time, and this is called as your direct current. I have represented the blue color. B and C, which are representing as your purple and your green color, varying current whose magnitude varies with time. And the last one is the alternating current whose magnitude varies continuously and direction changes periodically. Now, we can also say that what are the type of charge carriers. If we look at over here, solids, free electrons in case of conductors, no charge carriers in case of insulators, free electrons and holes in case of semiconductors. Now, holes are nothing but your missing electrons. Now, in case of liquids, the charge carriers are positive and negative ions in case of your electrolyte, and gases, your positive ions and electrons. Now, as we have already read that the direction of current is a scalar quantity, or I have to explain why it is a scalar quantity. If we say it, we can explain it by this way, the conventional current. Now, what is conventional current? By convention means the direction of flow of current is taken to be the direction of flow of positive charges. But earlier I have said that the flow of charges means that your flow of current is your direction of current, but it is called as conventional current. In the beginning, it was thought that the current is due to positive charges. So I have represented a diagrammatic representation over there that your conventional current is flowing from positive to negative, and your electric current is flowing from toward your negative to positive. So from this I can conclude, or we can conclude, the direction of flow of current is opposite to the conventional current. That is why the current has no direction and it is a scalar quantity. Now, the next term which I am explaining you, or which I will be telling you, and this is some sort of a question, or you can say the home assignment for you, that you will look for this term, drift velocity. Now, what is drift? Before going to this, the drift velocity is defined as the velocity with which the free electrons are drifted towards the positive terminal of the battery under the action of the applied electric field. So, where does this electric field come from? This is all in your first chapter, that whenever the charges are there, they have a field associated with it, and that field is called as your electric field. Now, this is a question for you, this is a query for you. We can discuss it also, you can see it also, that this, what is drift velocity? So, and I have also derived a relation, or not derived, I have written relationship over there. The relation between your current and drift velocity is I is equal to NEAVD, where I is the current and is the number of electron passing through a given cross section of area, which is represented by small a. E is the charge of electron, and Vd is the drift velocity. So what we can understand by drift velocity? Drift velocity is the velocity with which the electrons are getting drifted. Why they are getting drifted? Because in an metallic conductor, the electrons are free and they are in a random direction, moving in haphazard manner. Whenever we applied a potential difference, or whenever we applied electric field to it, they will make those electrons to drift towards the positive terminal of the battery, and this drifting of electrons and the velocity associated with it is called as your drift velocity. Now, this term, all of us must have read it earlier, that is called as resistance. Resistance, the resistance of conductor is the opposition offered by conductor to the flow of electric current flowing through it, and it is denoted by R, and R is equal to V by I. It is done from most famous Ohm's law. But the thing is, why the resistance is offered by a conductor? That is given by, or you can find it the answer over here, that R is equal to M upon Ne square tau multiplied by L by A, where this tau is called as a relaxation time. What is this relaxation time? Relaxation time is that time in which the time taken, or you can say the time between the two successive collisions of the electrons. Less be the time, more be the resistance. More be the time, less be the resistance. And the next term which is associated with it is the resistivity. Resistivity, you can say, it is a thing which depends upon the nature of the material. From here, we can differentiate that how much resistance is offered by a given conductor, given wire, which is suitable for the other thing. So, it is denoted by rho. Resistivity depends upon the nature of material and not on the geometrical dimensions of the conductor. So these are the few terms which are very helpful in studying, or you can reading the things. What is resistance? What is your resistivity? Similarly, what is conductance now? Conductance of a conductor is defined as the reciprocal of a resistance. That means it is denoted by capital G and its units are mho or Siemen. And the reciprocal of resistivity is called as your conductivity, and it is denoted by sigma. Now, this is the most important part of your resistance. As earlier I have told you that relaxation time tells us how much will be the resistance, but how your resistance behaves when you heat it. So, the relationship over here, that R is equal to R effective multiplied by 1 plus alpha T minus T external, और T2 minus T1 आप इसमें कर सकते हैं, और जो R effective रहेगा, that will be the original resistance with which you have changed with the time interval, and alpha is called as the coefficient of temperature of a given specified conductor material. So this is the relationship which we must know, or which we must be writing over here, that alpha tells us if it is positive, so that we can able to recognize over that material is a conductor, and if it is a negative, it will tell us that it is a semiconductor, because in case of your semiconductors, your resistance decreases with the increase in temperature. So we always say that semiconductors have negative coefficient of resistance of temperature. So this helps us in finding or making our this fuse wires, the various wires which are using in our home appliances. Now this is your color coding of carbon resistance. Now, how we can say this is a color coding of carbon resistance? All of you must have done something, or you can, if you have a small toy at your home, या कुछ ऐसा आपके पास घर में हो जो जिसमें कोई आपका एक सर्किट लगा हो, तो उसमें आप देखेंगे छोटे छोटे सिलेंड्रिकल फॉर्म में हरे या क्रीम कलर के, जिनके ऊपर 3 या 4 कलर की कलर कोडिंग की, कलर्स के बैंड्स की आपके कंपोनेंट लगे होते हैं. तो वो जो कंपोनेंट्स होते हैं वो हमारे कार्बन रेजिस्टेंस होते हैं. तो ये जो कार्बन रेजिस्टेंस है, यहाँ पर हमने इनको 3 चीज़ों में डिवाइड किया है. अगर आप इन चीज़ों को देखें तो हमने यहाँ पर इसको, जैसे कि हमने यहाँ पर डिफरेंट कलर्स लिए हैं, तो मैं इसकी थोड़ी ओरिएंटेशन चेंज करूँगा ताकि आप उसको देख पाएँ अच्छी तरह से. सो फर्स्ट इज योर ब्लैक, ब्राउन, रेड, ऑरेंज, येलो, ग्रीन, ब्लू, वायलेट, ग्रे एंड वाइट. नाउ यहाँ पर हम इसको याद कैसे रखते हैं उसका भी एक साथ में दिया गया है. दैट B.B. रॉय, Great Britain, has very good wife. This first B stands for black, second B stands for brown, third R stands for red, O is for your orange, Y is for yellow, G is for green, B is for blue, that is Britain, V is for violet, H don't have it, so you can skip that also. G good stands for your gray and Y stands for your white. So how we can do it or we can understand it? अगर आप देखेंगे तो पहली एग्जाम्पल है जो हमारे पास वो है BVB, दैट इज ब्राउन, वायलेट एंड ब्लैक. जो पहले 2 बैंड हैं, अगर आपके पास वहाँ डायग्राम में आप जब देख रहे हैं, जब आप टुवर्ड्स लेफ्ट टू राइट जाते हैं तो पहले 2 बैंड जो हैं वो नंबर रिप्रेजेंट करते हैं. नंबर्स जैसे कि ब्लैक है हमारे पास, ब्राउन है हमारे पास 1, वायलेट है हमारे पास 7, तो 1 और 7 लिख दिया. और जो थर्ड बैंड है वो मल्टीप्लायर रिप्रेजेंट करता है. मल्टीप्लायर 10 to the raised power anything जो उसका बैंड का कलर होगा. जैसे ब्लैक है तो ब्लैक का 0 है तो 10 raised power 0 किया है. और चौथी है गोल्ड. गोल्ड रिप्रेजेंट्स टॉलरेंस. टॉलरेंस यू कैन से कि कितनी रेंज तक हमारा जो रेजिस्टेंस है वो ऑफर करेगा करंट को, हमारी रेजिस्टेंस की रेंज क्या है. सिमिलरली अब यहाँ पे सेकेंड एग्जाम्पल देखिए जिसमें है ग्रीन, रेड, ब्लू और सिल्वर. ग्रीन का अगर आप नंबर देखेंगे तो वो 5 है तो 5 आ जाएगा. रेड का अगर आप नंबर देखेंगे तो वो 2 है तो 2 आ जाएगा. और ब्लू इज अवर मल्टीप्लायर, तो ब्लू इज अवर 10 raised to power 6. और सिल्वर की जो टॉलरेंस है वो है ±10%. सिमिलर टू दैट अगर आप थर्ड एग्जाम्पल देखते हैं तो वहाँ पे 3 बैंड है और चौथे बैंड पर कुछ नहीं दिया गया है. तो चौथे बैंड में जो है हमारे पास दैट इज कलरलेस. तो कलरलेस के केस में आप देखेंगे ब्राउन, दिस इज B इज योर, ऐसे उन्होंने 5 लिया है तो इन्होंने ग्रीन था तो उन्होंने ग्रीन लिया नहीं, उन्होंने ग्रीन ऊपर वाला ले लिया है. तो ब्राउन, वायलेट, ब्राउन करके अगर आप ब्राउन रखेंगे सो 1, वायलेट इज योर 7 एंड ब्लैक इज योर 10 raised to power 0 एंड ±20% जो आपको टॉलरेंस देगा. तो इसका मतलब ये हुआ कि जो थर्ड बैंड है उसमें हमारे पास इन जो 9 कलर्स हैं इन्हीं के बीच में कुछ होना चाहिए. ऐसा नहीं है. हमारे पास अब जो नई कलर कोडिंग है रेजिस्टेंस की वो इस तरह से है जिसको आप देखेंगे अभी कि हमारे पास थर्ड बैंड में गोल्ड और सिल्वर भी हो सकता है. उस तरह से जब आप मल्टीप्लायर करेंगे, जैसे यहाँ पे गोल्ड की हमने मल्टीप्लायर रखा है 10 raised to power -1, यहाँ 0.1 दिया गया है. सिल्वर को जो है वो 10 raised to power -2. तो ऐसा नहीं है कि थर्ड में उन तीनों की चीज़ें ही रहेंगी, उन 9 के 10 कलर्स ही रहेंगे. इन तीसरे बैंड में आप टॉलरेंस में, आप जो मल्टीप्लायर में इन 3 चीज़ों को भी यूज़ कर सकते हैं. तो टॉलरेंस तो आगे है ही उन चीज़ों की. सो इस तरह से आप कोई भी एक एग्जांपल ले लीजिए, अपने पास कोई भी एक डायग्राम बना लीजिए और कलर लगाते जाइए और उसमें से आप एग्जाम्पल्स को देखते जाइए, तो आप देखेंगे कि आप उसको सॉल्व कर पाएंगे. सिमिलर टू दैट कलर कोडिंग तो हमने एक और दी है, लेकिन ये हमें इसमें नहीं आएगी. लेकिन अगर आप पढ़ना चाहें तो आपके एक्स्ट्रा नॉलेज के लिए आप इसको देख सकते हैं. इसमें डॉट्स को लेके दिया जाता है कि जितने भी कलर्स हैं उसमें डॉट रिप्रेजेंट करेंगे कि उसमें टॉलरेंस क्या है, मल्टीप्लायर क्या है. बाकी नंबर सब वैसे का वैसा सेम रहता है. एंड all of you must have studied about the combination of resistance in series and resistance in parallel. तो यहाँ पर उसका रिजल्ट दिया है मैंने. तो ये सब चीज़ें आपने जो मैंने भी आपको बताई, ये सब आप देखिए इसको. अच्छी तरह से समझिए। अगर आपको कोई क्वेरी है, उसका मैंने अपना ईमेल स्टार्टिंग में दिया हुआ है, आप ईमेल ले सकते हैं और उसको चेंज करके देख सकते हैं। द मोस्ट इम्पॉर्टेंट थिंग, जो आपको एक बहुत अच्छी सी चीज़ जो मैं आपको अभी बताने वाला हूँ इसमें, जो आप देख सकते हैं, इज़ योर कंसेप्ट मैप। अगर आप इसको यूज़ करना चाहते हैं कंसेप्ट मैप में, तो ये इस तरह से है। ये आपको बहुत हेल्पफुल रहेगा चीज़ों को समझने के लिए। अभी ये ओपन होगा, मैं आपको दिखाता हूँ। अगर ये ओपन होता है तो